just say, I'm happy to answer that. All right, so first thing we're gonna do always is look at the calendar spreadsheet to see where we are. And as soon as I join this, there we go. Again, always welcome to join the Zoom meeting. It's not super advantageous today, but later on it will be. Okie dokie. And we'll make that look like that. No, not like that. Jeez. Full screen. Okay, so here we go. Do stop talking. Thank you. All right, so sure you're talking about computer science. I appreciate the enthusiasm, but do stop talking. Thank you. Today we're doing lesson 4. You're going to learn how binary works. You are in the final moments of your life and the portion that you didn't know how binary works. And in a few minutes, you will start the next part of your life where you do know how binary works. It might not be the most significant moment of your life, but it is certainly one of the moments of your life. So the lesson is lesson 4 that goes along with our current unit, which I'm pretty sure I have made visible. There are a couple of check for understandings at the end, but I want to wait on that. So a lot of students, not a lot, there is a category of students that will come in and before class starts, go right to the conclusion question. Again, I love the enthusiasm. That is a personality trait that will serve you well, but don't do it. It bothers me. Okay? I want you to learn and then not just like, I suppose being able to answer a short answer question with just like having the skills to answer a question without knowing the answer is a good skill, but don't. Okay, so what we are going to do, also, this being the first recording, you will have to have the knowledge of how to find it in order to use it, but you haven't done that yet. It doesn't exist. The replays will be linked in this column, and the replays will be YouTube videos so they don't expire the way Zoom meetings do. And it will be a link to a Google Slides. If I ever, why is everything bad? There we go. It'll be a link to a Google Slides. You don't need to log in. Just no clicking, no typing. Thank you. Hands off. So that's how you'll get to replays. Obviously, the replay doesn't exist yet, unless you're watching this replay and then, well, you found it. Congratulations. So here is the step 1. We are going to learn how binary works using the Flippy do. Okay. The Flippy do is a, it's not unique to this class or this curriculum. It is a, I don't want to say famous, but a widely used tool, a tangible, something that you can hold like an abacus or something like that for converting binary to decimal and decimal to binary. Okay. First, before you write anything, I will tell you when I want you to start writing. But we're going to sort of, like we did last time, discuss generalities for number systems using base 10, using decimal, aka regular numbers. We'll see how they work in like detail. Obviously, everyone knows how to count integers, 1, 2, 3, so on. But understanding what is causing that to work will help you understand what causes binary to work. Okay, so if we are doing base 10 and we are right justified, and like this is the decimal place, so this is the ones column, all the way to the right, it is the ones column, correct? Obviously. Then there's the tens column and the 100s column. Don't write this yet. This is just a primer. Okay, so I'm not going to do all of them. We'll just do 4 columns. That is not a 7. That's a 1. Boom. And so we are all on board with that, right? So what is, if we are doing base 10, 10 to the what is 1? 10 to the 0th power, and 0th is the ordinal name for 0. 10 to the 0th is 1. How do we get 10 to the what is 10? 10 to the first. 10 to the what is 100? 10 to the what is 1,000. Okay, so base 10, it works out to be 10 to the, and counting up, and 10 to the n, starting from 0. And it makes sense because think about how we talked about yesterday, number of options. You have 10 options if you only have one column, 0 through 9. You have 100 options, 10 times 10, if you have two columns, and so on. Okay, and if you have like the number, I don't know, I always use some 4,703. You have 4 1,000s, you have 7 100s, you have 0 10s, and you have 3 1s. If you have 4 1,000s, you have 4,000. If you have 7 100s, you have 700, and you have 0 and 3. If you add all these together, you get 4,703. Okay, nothing there should be new, but the principles should work. Okay, so here's what I want you to do. I want you to write 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2, and so on. I'm not going to say them all. Okay, so this is 2 to the 3rd column, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. Okay, and what is 2 to the 0th? 1. What is 2 to the 1st? 2 squared. 2 to the 3rd. 8. Well, I mean, you can just sort of see the pattern even if you're not doing the exponential arithmetic. Wait, is that right? No, I skipped one. Hold on a second. 2, 8, 16. Yeah, that's right. Through 32, 64, and 128. Okay, and I want you to write a 0 in every one of these boxes. Okay, and when you're done with those zeros, I want you to flip all the little tabs up at the bottom so that they cover up the zeros. Okay, so that they each fold up nice and neat. I cut them for you so we don't have to distribute scissors. And fold them up. And on the back, once it's folded, write a 1. Okay, and then hold tight and we'll talk about it. So binary works the same way. We're going to use the Flippy-Do to convert binary to decimal and decimal to binary. Okay, base 2 into base 10, base 10 into base 2. Now, it's the same way. I'm going to start out just by using 4. Oh, yeah, let's talk about terminology. Each 1 or 0 is called a bit. Okay, so if you have a binary number that's 1, 0, 1, 1, this is a 4-bit number. Okay, we frequently will see things in 8 bits, which is what we have a capacity here for. We have a capacity for 8 bits. 8 bits is a byte, B-Y-T-E. You need to know those numbers. Excuse me, those words. Okay, so if we have a, oh, also just for funsies, a 8-bit number is a byte, B-Y-T-E. A 4-bit number is jokingly referred to as a nibble. Just if you ever hear that, that's a half a joke at most. Okay, so we're going to start just learning things with with the first 4 bits. Okay, if I have a number that is a binary number that I said like 1, 0, 0, 1. Okay, that's a 4-bit number. This isn't 1001. Okay, so if you flip up your tab here, you'll have a 1. Don't flip this one, don't flip this one, and flip this one. Do flip the last one. Okay, so what does 1000, excuse me, I already messed up. 1001 mean? or what does that equal? And here's a meta concept is 1001. Well, hold on, let's convert it and then we'll discuss the deep stuff. So if you have a 1 in above or with the 8s, you have 8. We have 0 4s, we have 0 2s, and we have a 1. Okay? 1001 is equal to 9. But here's the thing. It's not equal to 9. It is 9. This is one way of writing 9. This is another way of writing 9. It is equally 9. It's not like convert this into decimal and you say 9. Oh yeah, because it's 9 in decimal. No, it's 9 in binary too. It is 9. It is the quantity 9. Okay? It's just like converting to another language. It isn't more, that the meaning of that word. It's just the other way that you communicate that idea. Okay, so for each of these, it's the same basic idea, and there are a couple of sort of characteristics, I guess you'd say. Okay, first of all, if I had an 8-bit number that was 1 0 1 1 0 1 0 1, is that an odd or an even number? This 8-bit number, is this an odd or an even number? It is an odd number. How do you know? If it ends in a 1, it has to be odd. If it ends in a 0, it has to be even. Okay, these are all, I forgot to write that. These are all even. Even plus an even is an even, plus an even, plus an even. Maybe we skip this one, doesn't matter. We add another even, add another even. It's all even. If you add 1, it's odd. Okay, so that's one characteristic. The other characteristic is, so we have, let me erase some things. What is the lowest number you can make with 4 bits? 0. 0 8s, 0 4s, 0 2s, 0 1s is 0. What is the highest number you can make with 4 bits? You can make 15. All 1s is the highest number you can make, and 8 plus, well, I already have that, 8 plus 4 plus 2 plus 1 is 12, 13, 14, 15. Okay, the highest number you can make is 15 with only 4 bits. 15. You can count from 0 to 15 using 4 bits. How many different options is that? You have 16 different options because 0 is one of the options. 0 to 15 means you have 16 different options. Look at the value of the next column. The value of the next column is however many different options you have for that. It's also one more than the value of all 1s. That is just a characteristic of it. You don't have to look into a deeper meaning, but it's a trick for figuring out some things just quickly without having to get out the flippy do. Okay, let me get rid of some things. Okay, what does, and then using those shortcuts without even needing arithmetic, what does 8 1s equal? 255. Okay, what the next column would be the 256's column, and all 1s is 1 less than that. Okay, if you've ever done graphic design, Photoshop, what have you, you may have seen like color values that are, pick a number, 0 to 255. This is that. Anytime you see the number 255, it is an 8-bit number. There you go. So the converting binary to decimal, which is the only thing we've done so far, is pretty easy. It is just addition. Okay. Converting decimal to binary is, you guessed it, subtraction. So if I have a decimal number, 37, that's the decimal way that you'd write out the value 37. How do you figure out the binary for 37? Well, you start on the other side, or you start on the left side, and you ask, can this number fit into this number? If the answer is no, you write a 0. Okay, 128 does not go into 37, so that's a 0. We ask it again, can 64 go into 37? It cannot, it gets a 0. Can 32 go into 37? It can, so it gets a 1, and we subtract 32 from here, which leaves us 5. Now that's our new number. Can 16 go into 5? It cannot. Can 8 go into 5? It cannot. Can 4 go into 5? It can, so it gets a 1, and we subtract 4. Our new number is 1. Again, an ugly 1. Does 2 go into 1? It does not. Does 1 go into 1? It does. This is the binary equivalent of 37. That's how it works. Okay, hopefully doing that should give you the basic idea. Question? What, like leading zeros? Do you mean like these first two zeros? Yes. If you are expected to write an 8-bit number, you do need to have leading zeros. There are like questions on worksheets and stuff that don't specify that you need to fill out. But yes, in computer science, you do need leading zeros. Although all the stuff we're learning at this point is what we'd call really low level. And here is a curiosity for computer science. Low level means complicated. High level means simplified. Now, of course, that's counterintuitive, except if you think about, this is a concept called abstraction, which is simplification. A high level view is like an airplane view of the ground. Like it's literally high level, but everything is simplified. You can't see all the details. Low level is how every wire in the city or pipes and whatever, it's low level means specific and complicated, or not complicated and difficult, but could more detail. Understanding how binary works is about, no wait, it is exactly the lowest level. It is the smallest amount of information. A bit is the smallest amount of information that you could have. It is either a 0 or 1. Okay, and you do need to understand these concepts for higher level stuff, excuse me, for more complicated stuff, higher level in the sense of like college and that sort of level computer science. But it's not really going to affect programming, but these are, like I said, you know, the concepts. Okay, so yes, leading zeros. I feel like I answered 2 separate questions than the one you asked, but you do need leading zeros if you're expecting, and that's another thing for protocols, like what the computer is expecting, they are expecting an 8-bit number. You need to give it 8 bits, where 8 ones or zeros, and so leading zeros. Okay, so the thing about a Flippy do, this tangible that you've created, you can use it as long as you want. You can't bring it into the AP exam, but you can make one there. And also, once you know how it works, can you put the work away for another class? This isn't that class. Thank you. Maybe when everyone's done for the day. Once you understand how a Flippy do works, you don't need it. If you have a pencil or a pen and some scratch paper, just write out powers of 2, 1, 2, 4, 8, etc., and you get a binary number that's 1, 1, 0, 1. You can just do the arithmetic in the margins with your pencil. Okay, 8, 4, and 1 is 13. Okay, the point of the Flippy do is just to sort of spread it out and understand like how the powers work for different columns, but converting binary to decimal or converting it back and forth, you can just get some space in the margins. Okay, so let's see here. The next thing we're going to do is we're going to apply this to this worksheet that exists. This area. Okay, so you need a yellow worksheet. Spread some around. Grab one, please. Naming period at the top. And you can use your Flippy do if you like. Well, okay, go ahead and grab one. And let's go like this. And what's up? Wait, say that again? And we're live. Okay, go ahead and take a look at your yellow worksheet. It should look like this. And name, date, and period at the top. Those are the first three questions. Point each, not joking. What just happened? Am I using the correct keyboard? Okay, so challenge one, all 4-bit numbers. Fill in the binary equivalent for the decimal numbers below. We've started the first three for you. Okay, so you can probably figure out the pattern here of decimals, of regular numbers. That goes all the way to, what's the last one here? 15. You can make 15, excuse me, you can count up to 15 using 4 bits, but that's 16 different numbers. Okay, so let's figure this out. Well, you're going to figure out almost all of it. But we have 2 is just a 1 in the 2's column. So 0010 is equal to 2. 3 means well, here, we can just write this up here. You can write it if you want to. 1, 2, 4, and 8. Okay, how do we get to 3? A 3 is a 2 and a 1. Okay, so that would be 0011. Okay, how do we get to 4? Well, we just need a 4. So that's 0, 1, 0, 0. Let's pick a random one. 14, maybe this is 13. Well, it definitely is 13. How do we get to 13? Well, we need an 8. A 4 gets us to 12, and a 1. So 1101 is 13. Okay, I'll give you a couple minutes to go ahead and finish that one. Seriously, name, date, period at the top. One, two, three, four, 5, 6, 7, 8, 9, 10. Go like this column is just 0 to 15 in order. 0, 1, 2, 3, 4, 5, 6, 7, up to 15. So yes, these need to be shifted here, and these need to be shifted there. Do you want a new worksheet so you don't have to erase everything? Just take a new worksheet and trash that one. We'll listen up for a second. Listen up for a second. Silencio. So the first part, if you're done, you can keep going. I'm not going to say stop. But you're not allowed to go ahead. You are, but we will regroup in 2 minutes. Proceed. Okay, so it should look like this. The ones column, or excuse me, the decimal column, 0 through 15. And the binaries, so 5 is a 4 and a 1, 0, 4, 0, 1. 6 is a 4 and a 2. 7 is a 4, 2, and a 1. 8 is just an 8. 9 is an 8 and a 1. 10 is an 8 and a 2. 11 is an 8, a 2, and a 1. 12 is an 8 and a 4. 13 is an 8, a 4, and a 1. 14 is an 8, a 4, and a 2. And 15 is all of them. Okay, there you go. 0 through 15 in 4-bit binary. Okay. Does anybody need guys, hold up a second. Again, I appreciate the enthusiasm, but silent. Does anybody need a quick re-explanation of how this works, this first part? Okay, good. Second part, all of the binary numbers with exactly a single 1. With 1, 1. Thank you. Grab one of those blue sheets and one of the yellow worksheets that's over there. Anywhere. Thank you. Okay. All of the binaries that are equal to 1, or excuse me, that have a single 1 in their all of the 8-bit numbers that have a single 1 in them. Okay, the next one here would be 0, 0, 0, 0, 1, 0, 0, 0. Okay, there is a single 1 in this 8-bit number, and it is equal to 8. Okay, I forgot this one. This is equal to 4. All right, hopefully you see the pattern in this one. Okay, I'll give you do another one. The next one would be a 1 in the 16s column. And you'll probably notice that when I write out an 8-bit number, it is common for people writing out 8-bit numbers to put like a little space in between, not a dash, but a little space. It makes it a little easier to read. Yeah, you can see it here. You will frequently see 8-bit numbers written out like that. Okay, and 0001, 0000 is 16. And you can hopefully figure out the last 3 on your own. Okay, I'm going to keep going to keep it moving. Well, hold up a second, folks. Hold up. You can do this first part on the back. It's just more of the same thing, but with a couple of tricky parts, and then some short answers. Okay, when you add a 0 to the right of a decimal number, it multiplies it by 10. 15 becomes 150, and so on. What similar result happens to the value of a binary number when you add a 0 to the right? For example, 11 becomes 110. What is the general transformation when you add a 0 to the right of a binary number? Okay, to the binary number 0011. Hey guys, again, so happy you're working on this, genuinely. It super distracts me when I'm trying to talk to everyone. I appreciate it as a favor. Thank you. Okay, do the binary numbers 0011 and 000011 have a same or different value? Explain. Would 2 bits be enough to assign a unique binary number to each vowel in the English language? And how many bits would you need if you wanted to count to the number 1000, to the decimal number 1000? Okay, so you can go ahead and do those. This is another example of an assignment that everyone will hand in their own work, but you may collaborate. I encourage it. And yeah, that's the last for the worksheet. And then the short answers I'll open up the short answers on code. And let's make those visible, and let's bring up, discuss them. Okay, so the short answers, or excuse me, the check, listen up, I need you for like another literally 70 to 80 seconds, okay? So for the check for understandings on code for lesson 4, which is what we're doing today, there are 4 check for understandings. First one is a multiple choice. 2 schools are merging to adapt, 2 schools are merging, and to adapt to the increased size of the student body, the school is changing to a system to keep track of IDs from a system that uses 4-bit binary numbers to one that uses 8-bit binary numbers, aka 1 byte. Which of the following best describes what effect the change will have numerically or value-wise? Adding bits. Each time we add another bit, what happens to the amount of numbers we can make? Okay, how many bits would you need to count all the students in class today? Just look around. Hold on, let's do a number. Let's say 30, okay? Or, I don't know, something other that's reasonable. Okay, and what are the similarities and differences between binary and decimal system? Okay, so the assignment for today is the yellow worksheet and the checks for understanding. The Flippy-Do is your computer science artifact to keep or to recycle. Do not leave it in the room. I will be frustrated to clean up a pile of them. Okay, and like I said, the link for replays will be, this word here will become a link. And yeah, that's it. Any questions about this, about binary, about decimal, about assignments and grades and points? Okay, it is due today. All of that. Ready, steady, go.